We're going to do a bit of an experiment dealing with rotation and rotational energy. It's going to be related to one of the labs that we did in class, rolling different objects down an inclined plane. I've got two objects here that we're going to take a look at. One is a regular bottle of water, still very room temperature, very sloshy. And then we've got this one, which is a frozen bottle of water. It is frozen solid. You can see the ice in there. To freeze it, I had to open it up and pour a little bit of water out because you may remember that when water freezes, it expands. So let's check the mass of it real quick. It's about 497, so just shy of 500 grams. The bottle of room temperature water is about 518, so we're missing about 20 grams of water in there. I had to pour some out so that this could freeze and not end up with a whole mess. But that's what I've got. These are the two objects that we're going to put and analyze, and I want you all to see what you can come up with on them. Now, they're pretty much identical. Let's see, I'll move this back. We've got this one here and this one here. I'll bring it up. We can see that they are pretty much the same radius. So if I put one over the other, part of this may be a little bit of parallax because we're closer to one versus the other, but I'm going to bring it down level. Here we go. We can see that this one is pretty much the same size as the other. I'll put them side by side. They're going to be about the same radius. So these are the objects that we're going to be working with. All right, we're going to see what the experiment is in just a moment. Okay, so here's what we're going to do with them. I've got the rock solid all the way through, very rigid. We've got the liquid here, very sloshy all the way through. We're going to do a repeat of the lab that we had taken a look at in class. We looked at many different shapes and rolled them down the inclined plane and found out things about how they roll. And you might check out the other video that I have related to this where we actually do the analysis of that. But we're going to take a look at a slightly different scenario. These two bottles are pretty much identical. They're the same radius. They've got about the same amount of water. There's a little bit less in the frozen one. Like I said, I had to get some out so that there's room for it to freeze and not explode. But they're pretty close to each other's mass. This one's about 515, 520 grams. This one's right at about 500. So they're about the same mass, if that makes a difference. My question is this. I'm going to put them both on the ramp, let go of them at the same time. Which one is going to get to the bottom of the ramp first? In other words, which one's going to be fastest? Or will they both reach at the same time? So think about what we had learned in class. See what you come up with as a possibility. Which of these, either the frozen or the liquid, will get to the bottom first, or will they reach at the same time? All right, here we go. This time I'm going to put the liquid or the solid one in front, so closest to the camera, and the liquid one in back. I'm going to put them both back as best I can to line them up, and I'm going to try and pull my hands away at the same time. Here we go. All right, well, we want multiple measurements. Never trust one measurement. I'll do two more like this. It looks like the liquid one, the one in back, keeps winning. Okay, well, maybe it's something about it being in the back. So let's go ahead and bring it up front. Here we go. Nope, there it goes. It's still winning. And the impact is starting to melt some of this ice. That's okay, though. It's still very solid, very solid. Let's see. Here we go. Hopefully that didn't knock my camera out of focus. Let's see. There we go. And then I think this was the way I had it. Liquid is now in front. Here we go. And there you have it. For some reason, despite being identical size, identical shape, at least as close as we can be, they're very, very close. And being nearly identical mass, even though we saw that mass didn't have a big effect on this anyway with the rolling objects, for some reason the liquid seems to constantly get to the bottom first. My question to you is, why? What's different about this? They're about the same mass, they're about the same size, so those are the main things we've talked about in class. This is going to be something a little more complex. I want you to think about rolling objects and the idea of energy. Rolling objects have an energy associated with them, so what's different about these two that might affect where that energy goes?